And welcome. So this session we are going to conduct that are going to prove the parallelogram law of forces. So this is applicable for the UGA students or in diploma students who is doing engineering in different branches that were taken first year admissions. For them it is important. So what is the statement here? That if two forces acting at a point be represented in magnitude and direction by the two adjacent sides of parallelogram, then their resultant is represented in the magnitude and direction by the diagonal of the parallelogram passing through that point. So here two forces, that forces are F1 that represented by line A and B, F2 will be represented by line A and C. So this force and this force taken. So to make it parallelograms, what we do, what we supposed to do here, we will draw a parallel line to AB that will connecting, that will starting from the end of point C, end of line AC. So this one, and a parallel line to AC that is drawn. Again, it drawn the diagonal of this parallelogram, and these two forces, that F1 and F2, it makes angle alpha, and after drawing the diagonals this makes angle theta with the F1. So what we do, we will extend the line AB further up to E, and we will drop a perpendicular line from point D, and that's meeting at point E. So as this line AC and BD both are parallel lines, so whatever AC made angle with AB, that is alpha, same angle will be made by in between BE and BD. So how? So our main motive is to calculate uh, two parameters, that is one is FR, that is resultant force, then second one is theta, that is called direction. So how we are going to do this, that we have to see. What we will see, or consider triangle BDE. This triangle we have to consider, and we will start dealing with this. First we will take cos alpha in this triangle. So cos alpha will be this BE by BD, means base by hypotenuse. So BE by BD, so that can be written, B will be same, and BD will be equal to F2, because both are parallel lines. So we can write BE divided by BD, that is F2. So we can get here BE is equal to F2 cos alpha. So this is our first equation. Again we will take sin alpha. How we can write sin alpha? Sin alpha will be this height ED by BD. So that will take ED by BD, that ED by BD, that is equal to ED will be as usual, and BD will be again F2. So ED by F2, that you can write ED is equal to F2 sin alpha. So this is equation number 2. Next what we will do, we will consider triangle, because you have to calculate the diagonals. For that we will consider a perfect triangle. In that perfect triangles we are going to apply Pythagoras theorem. So here from triangle AE and D, so this triangle will, so what we will do here, so according to Pythagoras theorem, AE square plus DE square is equal to AD square. So here if you will see AD, if you see this A to E, here two lines is connecting together, that is AB and BE. So if you can write here AB plus BE, that to be whole square, plus DE square is equal to AD square. What next we can write? Again, by seeing this figure, AB will be given F1 plus BE. B will be given this one, F2 cos alpha. So here you can write F2 cos alpha square plus DE. D will be given F2 sin alpha. So here you can write F2 sin alpha, that 2 square is equal to AD. AD is given the diagonal line, so this line will be the AD. So directly we can write that is FR. So here that value is of that line is FR, that we have given in the diagram. So that is square. Again we will do the squaring. So here we can write F1 square plus F2 square cos square alpha plus 2 F1 F2 cos alpha plus F2 square sin square alpha. So F2 square sin square alpha, that is equal to FR square. So next what we will do, these two terms, that F2 square cos square alpha and F2 square sin square alpha, that F2 square will be common. So here we can write F1 square plus F2 square plus 2 F1 F2 cos alpha is equal to FR square. So our intention is to find FR. So here we will get FR is equal to root over F1 square plus F2 square plus 2 F1 F2 cos alpha. So this we have done. So this is the our motive, that to calculate this equations. Next we will calculate the direction. So direction is here tan direction, direction of the angle, direction of resultant force FR. So that to determine this, we will write tan theta is equal to, so if you take the theta here, so what is tan theta here? That height ED divided by AE, ED divided by AE, ED divided by AE. So ED will be the ED only, A will be divided in two parts, AB plus BE, that is AB plus BE. So that we can write here ED is equal to, that we have calculated, F2 sin alpha divided by AB is given, that force F1 plus B is given F2 cos alpha, and this theta we can again write tan inverse F2 sin alpha divided by F1 plus F2 cos alpha. So this is our derivation for law of parallelograms. So this is the final equations that we have derived. Thank you so much for listening.